We have found a new planet, home to octillions of the most extreme beings in the universe. These creatures live in a deadly hellscape, crushed by mountains and starved of oxygen. They are cooked alive and bathed in salt or radiation, yet they survive for millions of years. This planet is not in space. It is hidden deep inside the crust of our own Earth. This is the deep biosphere, a massive realm we only truly discovered very recently. Its volume is twice as large as all the Earth's oceans combined, filled with microbes. There are more microbes here than on the rest of the entire planet's surface combined. Their total biomass is 20 times greater than all humans, livestock, and animal wildlife combined.
Let's descend into this deadly world where the normal rules for life simply do not apply. We are going deeper and deeper into the unknown reaches of the Earth's interior.
Deep life seems to be everywhere, below the oceans, and even near active volcanoes.
It exists beneath the glaciers of Antarctica, and under every landscape we can imagine.
It is even beneath the places where we live and work every single day. We will use a special science drill to start our journey in familiar territory. On land, in the soil, plants grow and animals roam in the sunlight. If Earth were an onion, this surface would be the very top of the top layer. Soil is a partnership of air, water, minerals, and organic matter bathed in energy.
Life lives in luxury here, exploiting this paradise to produce massive amounts of biomass.
Plants produce 30 times the biomass of all Earth's animals in a constant cycle.
A tiny fraction of this biomass is buried deeper, supplying resources for millions of years.
As we dig deeper, air is squeezed out, and we reach the water table.
This zone is saturated with groundwater, rich in minerals and some organic matter. Roots from ambitious plants reach down here, and scavengers live off the decay.
This layer is cold, still warming up from the most recent ice age.
We reach bedrock, a solid foundation for all the less solid stuff above it.
Bedrock is home to fractures filled with water, buried hundreds of meters below the surface.
Here in the bedrock, we are in a weird planet inside the planet.
As we drill further down, temperatures begin to rise and pressure increases.
We must activate the heat shield to survive the extreme conditions below.
Under 400 meters of rock, the pressure is like the surface of Venus. We drill faster now, deeper than the world's tallest buildings are tall.
There is almost no oxygen left, and the heat is becoming intense. We finally stop almost 4 kilometers down, with massive rock pressing above us. The pressure here is as intense as the bottom of the Mariana Trench. It is over 100 degrees Celsius here, even hotter near magma plumes.
Heat comes from Earth's formation and the decay of radioactive elements like uranium.
Despite the salt and heat, life is thriving deep inside the rock.
Solid rock is not actually solid. It is filled with cracks and tiny pores.
Up to 40% of their volume is actually empty space for life.
We have found a gigantic, planet-spanning system of microcaves filled with water.
Just like the atmosphere creates weather, rocks are mixing to create rock weather.
Submerged mountain ranges are shifting and ripping, crashing and merging together constantly. Continents smash together with the energy of millions of nuclear weapons.
Countless tiny earthquakes rip open new fissures and pathways for deep life. In this pressure cooker, minerals are forged and organic molecules are created.
Let's venture into the system of tiny caves and meet some of them. Trillions of microbes live down here, and they are incredibly hardcore survivors.
Some have big genomes, forming their own ecosystems entirely on their own. Meet Disulfurudus audax aviator, a bacterium that synthesizes its own food from rock. It turns carbon or sulfur from the rock into organic substances to survive. If conditions get too extreme, it kills itself to survive by forming a spore.
It divides and swallows its smaller part, forming a cell within a cell. The outer cell then kills itself, leaving the spore to float for thousands of years. It waits until it finds a good place to spring back to life again.
Others, like the Archaea ultiarchaeum, have a rare double membrane for protection. They shoot out grappling hooks to tether themselves in cracks filled with water.
They harvest carbon dioxide to create biomass, and may even eat hydrogen.
Conditions are so harsh that microbes share the work by forming consortia. They knit themselves together in a biofilm, a sticky net against the extremes. These miniature cells are each good at one specific thing to help the group. One type eats methane and excretes electrons for the second type to eat.
The second type converts sulfate into sulfide for the third microbe to consume.
Some eat iron, while others turn nitrogen into biomass using electrons. They use stuff that is poisonous to most animals to make food and energy.
Resources and energy are super hard to come by in this deep world. The most intense strategy for survival here is to simply live forever. Deep microbes consume very little and conserve their energy like monks.
Their metabolism is 1,000,000 times slower than microbes at the surface.
They had a meal when you were born and are still digesting it.
Some even slowly cannibalize themselves to survive in a slow limbo. A sudden influx of resources arrives by chance, and they spring into action.
They reproduce and can live for centuries, maybe even millions of years.
Unless they are hunted to death by multicellular predators in the dark.
We have found asexual worms, 100 times longer than microbes, hunting here.
It is not clear if they originated here or were carried by earthquakes.
There are other fierce predators, like rotifers or arthropods in the depths.
We wish we could tell you more, but we don't know much yet.
Drilling down could contaminate the samples with microbes from the surface.
We have brought living ones from deep mines into the lab to study.
It is hard to simulate the conditions they feel comfortable in. Microbes live so slowly that nothing might happen for a very long time. We learn about them by looking at what their genes could do.
The diversity of life in the deep biosphere must be absolutely staggering. This is a proper frontier of science, super hard to study effectively.
There is so much more undiscovered mystery that could bring us progress.
Could there be deep biospheres all over the universe on other planets?
Maybe all you need is internal heat and a specific chemical composition. We may accidentally learn about life in the universe from our feet.